Let us continue with the last example. Now simplifying this, we get this powers. Now again, like in earlier example, first and last term combined together, x raised to 6 plus 1 upon x raised to 6, plus second and second last term, 6 gets common, x raised to 4 plus 1 upon x raised to 4, plus this third and third last term, 15 common, x square plus 1 upon x square, and 20 remain as it is. Now one more, write down one more note here, like sine formula. Here we have some cos formula also. X plus 1 upon x is 2 cos theta, x square plus 1 upon x square is 2 cos 2 theta, x raised to 4 plus 1 upon x raised to 4 is 2 cos 4 theta, and so on. Okay, like this x raised to 6 plus 1 upon x raised to 6 is 2 cos 6 theta. Whatever the power here, we have to multiply that angle, that number with that angle. Okay, plus 6 as it is, this is 2, put the bracket, 2 cos 4 theta, plus 15 as it is, this is 2 cos 2 theta, plus this 20 as it is. Now this 2 2 2 2 everywhere, 2 is common, take common 2 and cancel with this 64, we get 32 here, and cos 6 theta here, 6 cos 4 theta remain, 15 cos 2 theta, and plus by taking 2 common here, 10 remains. Okay, this is our answer for expansion for cos raised to 6 theta. Similar way, we can expand any power of cos and any power of sine using the same method. Now this is the homework for you. Expand cos raised to 7 theta. Use Pascal triangle and expand here. Instead of 6, you have to just replace by 7. Answer is this. Okay. Now let us see next. Prove that cos raised to 6 theta minus sine raised to 6 theta is equal to 1 upon 16 cos 6 theta plus 15 sine 2 theta. In this question, the cos raised to 6 theta minus subtraction is there of two trigonometries with the same power. Now in this example, we have to find out cos raised to 6 theta and sine raised to 6 theta, and just take the subtraction of these two terms. Okay, now sine raised to 6 theta, using earlier method, we have already expand sine raised to 5. Well, already cos raised to 6 we have expand here, and this is the homework in this example for you. Expand sine raised to 6 theta in the same way. Answer for sine raised to 6 theta is this. Okay, and cos raised to 6 theta we have just solved. Now take the subtraction of cos raised to 6 minus this. We have to subtract this, that way this minus becomes plus. Now consider this is a homework. We have to solve this sine raised to 6 expansion here in this example. Okay, after finding sine raised to 6 and cos raised to 6, just repeat these steps as it is here and subtract this, we get this terms becomes plus here. Okay, this is cos raised to 6, minus becomes plus, sine raised to 6 is this. Okay, now take 1 upon 32 is a common, and in this bracket cos 6 theta is get add, we get 2 times cos 6 theta. This two term is same and opposite in sign, gets cancelled. This term gets also add, 50 plus 15 30 cos 2 theta, and 10 minus 10 gets cancelled. This is the answer. Now take 2 common and cancel with the 32, we get 16 cos 6 theta plus the 15 remains. By taking 2 common, cos 2 theta. This is our answer. Okay. Now here one more homework for you. Prove that cos raised to 8 theta plus sine raised to 8 theta is equal to this. In the similar way, you have to find out cos raised to 8 theta using, instead of 6 you have to take 8. Expand the Pascal triangle till 8. Okay, then find out cos raised to 8, then find out sin raised to 8 also using same method. Earlier we have seen sin raised to 5, here sin raised to 7. Now expand sin raised to 8, okay, and add these two like this. Here subtraction is there, you have to just add these two expansions, you will get this answer. Okay, this is the homework for you. Let us see next. Find. Now here multiplication of two trigonometry is there. Find sin raised to 4 theta into cos cube theta. The method is different. You don't need to find out sin raised to 4 and cos cube separately. Here some techniques are there, arithmetic techniques are there. Let us start with x is equal to cos theta plus I sin theta. 1 upon x becomes cos theta minus I sin theta. Both trigonometries are there, therefore write down both the equations. X plus 1 upon x is 2 cos theta, x minus 1 upon x is 2I sin theta. Now for cos, cube is there, that's why take cube on both sides. We get x plus 1 upon x cube is equal to 2 cube cos cube theta. And for sin raised to 4, on take on both sides, we get x minus 1 upon x raised to 4 is equal to 2 raised to 4 I raised to 4 sin raised to 4 theta. I raised to 4 becomes I square, that is minus minus plus. 2 raised to 4, keep it as it is, sin raised to 4 theta. Okay, now we have to multiply, we want this multiplication, that's why multiply these two equations simultaneously. LHS into LHS, keep it in LHS, and RHS into RHS, keep it that into RHS. We get multiply above two equations, we get 2 cube cos cube theta into 2 raised to 4 sin raised to 4 theta is equal to this term x plus 1 by x raised to cube into this 1 x minus 1 upon x raised to 4. Okay, now on LHS side it becomes 2, this is a 4 term in multiplication, 2 raised to cube 2 cube into 2 raised to 4, base is same, indices get add, 4 plus 3 is 7, 2 raised to 7 sin raised to 4 theta cos cube theta as it is. Now in first bracket is x plus 1 by x, other bracket is x minus 1 by x, and find out the lowest indices among the both the indices. Here is 4, here is 3, 3 is the lowest, that's why we have to split this number into 3 plus 1. Okay, find out what is the procedure, find out the lowest number, lowest indice amongst these two, and make other indice and split the other indice in terms of that number. Okay, here 3 is there, that's why we have to split this 4. You cannot split 3 in terms of 4, that's why we have to find out the lowest indice here, that's why 3 is the lowest, we have to split 4 into 3 plus 1. Okay, this is the first step. Now x plus 1, this as it is, this is 4 split into 3 plus 1. Now this is a plus b into a minus b, combine these two brackets and raise to power as it is 3. Just combine these two brackets and power raised to, combine this power as 3. Okay, because we can do this, this is arithmetic. A raised to m if it is there and b raised to m is there, then we can combine a b raised to m, same indice if it is same indice there. Okay, like that only, so indice is same, that's why combine these two raised to 3, this keep as it is. Now use the formula a plus b into a minus b, that is a square minus b square, right? Here we are using a plus b into a minus b formula, that is a square minus b square. Okay, now this bracket as it is. Now this is your a minus b bracket cube expansion. We have to expand this bracket, that a minus b bracket cube. What is a minus b bracket cube? A cube minus 3a square b plus 3ab square minus b cube. What is a? X square. What is b? 1 upon x square. Keep those in the bracket as it is. Now let us start with the expansion. Bracket, keep the bracket, square bracket. This term as it is here. A cube minus 3a square b plus 3ab square minus b cube. Put the brackets everywhere, okay, so that no mistakes should be there. X minus 1 by x as it is, okay. Now expand this. Indice raised to indice becomes multiplication of indice, right? This a raised to m raised to n is nothing but a raised to m into n, okay. A raised to m into a raised to n. When base is same, indice gets add. When base is 1 and indice raised to indice is there, the indice becomes multiplication of indices, okay. That's why it becomes x square cube means 3 to the 6, x raised to 6 minus 3 x raised to 4 into 1 upon x square plus 3x square 1 upon x raised to 4 minus 1 upon 3 to the 1 upon x raised to 6. This bracket as it is. Now cancel the indices. X raised to 6 minus 3 here x square remains plus 3 here denominator x square remains minus 1 upon x raised to 6 into this bracket as it is, okay. Now we have to multiply this bracket simultaneously, okay. Now multiply the lowest first with x into this bracket. We get x raised to 7 minus 3x cube plus 3 1 upon x remains here by multiplying x minus 1 upon x raised to 5 remains. Put this minus as it is, put the bracket because minus sign is there. Now multiply with 1 minus x 1 upon x. With this we get x raised to 5 minus 3x only 1x cancel plus 3 1 upon x square becomes 1 upon x cube minus last this is minus 1 upon x raised to 7. Now remove this bracket on next step. Minus becomes plus, plus becomes minus. We get this term as it is, okay. Now this is the most simplified form. Now again same we are doing first and last term together, x raised to 7 plus 1 upon x raised to 7. Here second and second last term 3 get common, x cube minus also common, x cube plus 1 upon x cube plus this term 3 gets common, x plus keep the numerator term first and denominator term second, x plus 1 upon x, and last minus common, x raised to 5 plus 1 upon x raised to 5, okay. Keep the brackets. Now again we know this is equal, this is LHS as it is here, this is cos term 2 cos 7 theta minus 3 as it is 2 cos 3 theta plus 3 as it is 2 cos theta minus 2 cos 5 theta. This is the expansion. Again here 2 2 2 everywhere 2, and on LHS side also 2, cancel 1 2 everywhere. We get 2 raised to 6 sin raised to 4 cos cube becomes cos 7 theta, 2 cancel 3 cos 3 theta plus 3 cos theta minus cos 2 cancel cos 5 theta. Now we want expansion of sin raised to 4 cos cube, therefore take 2 raised to 6 on this side in the denominator and put the bracket to the term. This is our answer for expansion of multiplication of two trigonometry, okay. We have to make this arithmetic shortcuts or arithmetic simplifications, okay. Similar way, let us see one more. Sin raised to 5 into cos square, we have to show that this is the answer. This is a prove that question, okay. Answer is given already. Now let us start. X is equal to cos theta plus I sin theta. 1 upon x is cos theta minus I sin theta. X plus 1 by x is 2 cos theta. X minus 1 by x is 2I sin theta. Now add, taking we need cos square, that's why I take square on both sides of this equation, and we need sin raised to 5, that's why I take raised to 5 on both the side. We get 2 raised to 5, I raised to 5. I raised to 5 becomes I only, and sine raised to 5 theta. Now multiply these two equations simultaneously. We get this into this is equal to this bracket into this bracket. Okay. Now what we have to do? We have to search the lowest indice. Lowest indice is 2. That's why we have to split this 5 into 2 plus 3. That's why here 3 raised to 3 raised to 2. Split this bracket as it is. Okay. Now keep this bracket as it is here, and here combine these two raised to square as it is. Multiplication of these two. Now again use a plus b into a minus b bracket formula. We get a square minus this b square. Okay. Raised to square as it is. Now expansion of these two brackets we have to do. This is a minus b bracket cube as it is. A cube minus 3a square b plus 3ab square minus b cube. This is the expansion of this first bracket. And this bracket is a minus b bracket square. A square, this is x square square. This is a term, this is b term. A square minus 2ab plus b square. Okay, put the bracket everywhere. Okay, now cancel out this x square here, x raised to 4 is there, here x square is x raised to 4, indice raised to indices, multiplication of indices, and here cancel with this x, we get 1x, here cancel denominator 1x, we get 1 upon x, here minus 1 upon x cube. And rest of the, we have to multiply all these brackets, multiply the lowest or x raised to 4, or start with this x raised to 4 into bracket, 2 into this bracket, this into this bracket, add all these terms and simplify, you will get this answer. Okay, like earlier example. It's a homework for you. Now one more homework for you is this. Prove that 32 sine raised to 4 cos square. Here already 32 is there. Okay, you can add this 32 at the end of the this thing. Okay, is equal to cos 6 theta minus 2 cos 4 theta minus cos 2 theta plus 2. Similar way, expand this sine raised to 4 into cos square like earlier. Okay, here sine raised to 4 cos cube we have seen, here sine raised to 4 cos square we want. Okay, take only square here in this example. Okay, now let us see next example. If sine raised to 4 theta into cos cube theta is this. Okay, in this example expansion of this is given, but in this expansion a1 a3 a5 a7, these are not numbers, these are constants. Okay, alphabets are there. Prove that, what we have to prove that a1 plus 9 a3 plus 25 a5 49 a7, these are notations, a1 a3 a5, these are just notation for numbers. We have to prove this equation, means we have to find out a1 a3 a5 a7, and these are 4 numbers in this series. That means we have to find this answer first. Sine raised to 4 cos cube theta, and this example we have already seen first. Sine raised to 4 cos cube, you have to solve this example as it is till this here as it is. Just carry the same steps here and write down the same steps, and we get this answer. Sine raised to 4 cos cube is this. Okay, now call this equation given equation number 1, and this our answer number 2. Now comparing these two equations, LHS side is same, that's why RHS side coefficients must be same. Cos theta coefficient is a1, here cos theta coefficient is 3 into 1 upon 2 raised to 6. That's why a1 value is 3 upon 2 raised to 6. a3 is cos 3 theta coefficient. Cos 3 theta coefficient is minus 3 with sign. With sign we have to take. minus 3 and this 1 upon 2 raised to 6. A5 is cos 5 theta coefficient. Cos 5 theta coefficient is minus 1. No number is there, that means 1 is there. Minus 1 upon 2 raised to 6. And A7 is cos 7 theta coefficient. Cos 7 theta coefficient is 1 upon, simply 1 upon 2 raised to 6. By comparing the RHS and LHS side, we get these constants. Once we get this constant, consider this LHS side. A1 plus 9, A3 plus 25, A5 plus 49, A7. And we have to make sure that answer should be 0. Add this. A1 is 3 upon 2 raised to 6 minus plus A3. A3 is minus 9 into this 3, 27 upon 2 raised to 6 plus 25 into A5. 25 A5 is this minus 25 upon 2 raised to 6 plus 49 into A7. 49 into this 1 upon A raised to 2 raised to 6. The denominator is same. That's why add this all numerator. 3 minus 27 minus 25 plus 49. Answer is add all this, we get 0, which is our RHS. You can write down, hence proof. Okay. Okay, let us start with the next point of this chapter, roots of the complex number. We have to find out the root of the given complex number. They have asked for finding out the root or solve the equations, means finding out the roots, or find out the all values of the given equation, means the same question, that is finding out the roots of the equation. Let us start with some notes. Cos theta plus I sin theta raised to 1 upon n means the nth root of the, whatever reverse 1 by n means indice. If 2 square is there, 2 raised to 2 means square of 2, right? If we reverse this 2, 1 upon 2, it becomes a root of 2, right? Like for example, 2 cube means 2 raised to 3 means cube of 2. If you reverse this 3, it becomes 2 raised to 1 by 3 means cube root, it becomes cube root of 2. Similarly, if 2 raised to n is there means nth indice of 2. If we reverse this 1 by n, it becomes nth root of 2, right? Similar way, we are now consider the Morris Theorem, and indice as 1 by n means nth root of this complex number. Okay, now how to use these steps, how to solve the examples. We need some steps to expand this 1 upon n. We need to add equal to 2k pi. We need to add theta plus 2k pi or 2k pi plus theta. Before taking 1 by n inside, you have to add 2k pi in the theta. This is the step. Cos of 2k pi plus theta plus I sine same angle. You have to put the same angle like cos 2k pi plus theta raised to 1 upon n. Now you can take 1 upon n inside using De Morris theorem. It is De Morris theorem. Okay, 1 upon n, when it becomes cos of 2k pi plus theta upon n plus I sine 2k pi plus theta upon n. And k values, k is a start from 0, 1, 2, 3 up to infinity. And how much k values we have to take? The number less than n. Okay, if n value is 4, you have to take up to 3. 0, 1, 2, totality we need 4 numbers. If it is 5, then we need total 5 number, that means one number less than 5, that means end with the 4. 0, 1, 2, 3, 4, like that. Okay, we need that much number of roots. This is the one basic step in every example. Now we need some steps here also. 1 we can write it as cos 0 plus I sin 0, because sin 0 is 0, cos 0 is 1. The answer becomes 1 on both sides. That means yeah, that is we have to use these steps in some examples to find out the roots. 1 we have to use as cos 0 plus I sin 0, minus 1 as cos pi plus I sin pi, I as cos pi by 2 plus I sin pi by 2, and minus I as cos pi by 2 minus I sin pi by 2. You have to mug up these 4 equations. Okay, if you calculate the cos pi by 2 sin pi by 2 on calculator, you will get the RHS side, LHS side. Okay, now next note, cos of 2 pi minus theta is cos theta, sin of 2 pi minus theta is minus sin theta. Similarly, cos pi plus theta is minus cos theta, sin pi plus theta is minus sin theta. These are the formula we know already. Now we have to use these notes. Let us start. Or